Explanation of the typical power interruption and restoration sequence for a three-phase spot network reception. This is a power reception method used in data centers in Japan, and there is a three-line spot network power reception method. This video explains a typical power outage recovery sequence. In reality, it will vary depending on the equipment configuration and design philosophy at each site. Please listen to the explanation for reference only. Power outage determination. The three-line spot network power reception method receives power from the power company over three lines. Normally, a power outage sequence begins when two lines detect a power outage. This time, we will explain the procedure for creating a simulated two-line power outage by manually stopping line 2 first. Then, first, manually open 52R2. Then, 52S2 has reverse power cutoff characteristics and automatically opens. Now, line 2 will stop, so RY2 will detect a power outage. Next, I will explain how to stop line 1. First, open 52R1 manually. Then, as before, 52S1 will automatically open due to its reverse power cutoff characteristics. Line 1 will now stop and RY1 will detect a power outage. The figure shows lines 1 and 2 stopped. In other words, two lines are down. At my site, there is a power outage determination selection switch that allows you to choose whether to start the power outage sequence on 2 or 3 lines. Normally, I think you select 2-line outage, so the power outage sequence will start after this. I will explain the power outage sequence. When the power outage sequence starts, 52S1 to 3 will automatically open. Since 52S1 and 52S2 have already been automatically opened, the remaining 52S3 will automatically open. Then, the high voltage bus will lose power. Due to a power outage on the high voltage bus, under voltage relays 27B1, B2, and B3 are activated. When there's a power outage, it operates because the voltage falls short of its normal level. Generators G1 and G2 automatically start upon detecting the operation of the under voltage relay. In Japan, voltage is normally established within 40 seconds. Simply put, voltage establishment is the state in which the generator has reached a certain rotation speed and the voltage is suitable for power transmission. At the same time, feeder circuit breakers 52F1 to 52F7 and 52FC will automatically open at different times. When connecting the generator with all devices connected, there is a possibility of a large current flowing at that moment, potentially activating various protection devices of the generator. To prevent, we will proceed with the explanation by assuming that generator G1 has established voltage first. In reality, the faster one is connected to the busbar first. When G1 voltage is established, 52G1 is automatically turned on. Then, electricity is sent to the busbar, so power is restored to the busbar. Since the under voltage relay returns to normal, 27B1, B2, and B3 will automatically return. When the under voltage relay automatically resets, feeder circuit breakers 52F1 through F7 will automatically close at different times. However, 52FC, which is connected to the phase advance capacitor. During this time, generator G2 is starting to control itself in order to match the voltage, frequency, and phase with the bus that is already transmitting electricity. If these match, circuit breaker 52G2 will automatically close. Once G2 is synchronized with the busbar, 52G2 will automatically turn on and supply electricity from the G2 generator. After all the power outage sequences are completed, it will look like this figure. This concludes the brief explanation of the power outage sequence. Power restoration determination. Next, I will explain the power recovery sequence. First, we need to create the conditions to start the power restoration sequence, so we will explain power restoration determination. This diagram shows a power outage and a generator is providing electricity. In order to restore power to line 1, 52R1 is manually turned on. Then, electricity is sent to the transformer on the secondary side of 52R1, so RI1 automatically returns to normal. Power has been restored to line 1, so power is now being received on line 2. At the site I experienced, there was a select switch for automatic and semi-automatic, but it was semi-automatic. So the power recovery sequence would not start unless you pressed the power recovery sequence start button. Description of power recovery sequence start. The figure shows the state immediately after the power recovery sequence has started. 52G1 and G2 will open automatically first. Normally, circuit breakers 52S1 to S3 on the power company side and circuit breakers 52G1 and G2 on the generator side form an interlock circuit to prevent them from being closed at the same time. Therefore, 52G1 and G2 will be automatically opened first. The electricity that was being sent from the generator has stopped, resulting in a power outage to the high voltage bus. Since the high voltage bus has experienced a power outage, under voltage relays 27B1, B2, and B3 will detect the power outage, just as in the power outage sequence. Next, feeder circuit breakers 52F1 to 52F7 open automatically at different times, similar to the power outage sequence. When all feeder circuit breakers open automatically, 52S1 automatically closes due to its no voltage closing characteristic. Then, electricity is sent to the busbar, so power is restored to the busbar. Since the under voltage relay returns to normal, 27B1, B2, and B3 will automatically return. When the under voltage relay automatically returns, feeder circuit breakers 52F1 to F7 and FC will be automatically closed at different times. Finally, 52S3 automatically turns on with its differential voltage turning on characteristic. This is the power restoration sequence on the power receiving and substation equipment side. In this diagram, line 2 has not been restored, so 52R2 will be turned on manually after this. Then, electricity is sent to the transformer on the secondary side of 52R2, so RI2 automatically returns to normal. Since power has been restored to line 2, 52S2 will automatically turn on with its differential voltage turning on characteristics. Generators G1 and G2 are automatically stopped by the generator control circuit. I think the time from the start of the power restoration sequence until the generator stops varies depending on the site. If you want to know, please contact the manufacturer. When all power restoration sequences and operations are completed, the system will return to being supplied with power from the power company. As control equipment gets older, it is expected that control will stop midway due to aging and other factors. Even in that case, if you understand the overall control flow, I think you can respond quickly. I hope this explanatory video is of some use to you. This concludes the explanation of the general power outage recovery sequence for the 3-line spot network power reception adopted in Japan. Thank you for your attention.